Hello students, how are you all? I am Gurmeet Singh and welcome you to CREATA classes and also welcome to our complete series on trigonometry for class 10 student. In this lecture or in this series, we will cover all these lectures using the power of visualization. You will love our unique way of teaching. Apart from this lecture, we are also having a complete PDF of the formula and concept list. Check out the link in the description. And we also have the cues related to the various trigonometric questions. To check the level of your understanding of the concept, check the link in the description. And especially in this lecture, we will cover NCERT example questions, question number 1 to question number 5 related to trigonometric ratios. So without taking any further time, let's start the lecture. Best of luck. Here it is. Example 1. Given tan A is equal to 4 by 3, find the other trigonometric ratios of the angle A. In this question, the value of tan A is given, which is 4 by 3. Here tan A is given, it means A is the trigonometric angle. Let's take a right angle triangle ABC, which is having the trigonometric angle at angle A. Got it? Tan A is given. In the theory part, we have seen that tan theta, where theta is the trigonometric angle. Here angle A is the trigonometric angle. Further, we know the formula of tan, that is tan theta we have done as perpendicular over base. Here tan A will also be equal to perpendicular over base. And if you observe in the given figure, perpendicular is BC. Why BC is perpendicular? Perpendicular is the side which is opposite to trigonometric angle. Here angle A is the trigonometric angle, so the side opposite to this angle is the side BC. So we got BC as perpendicular. And why AB is the base? Base is the side which is between the trigonometric angle and the 90-degree angle. So here AB is the base. So we got tan A is equal to BC upon AB, which is given as 4 upon 3. By looking at this equation, we cannot say, note that we cannot say BC is equal to 4 and AB is equal to 3. We cannot say this. Why? Because BC upon AB can also be like 8 upon 6, which on solving will be 4 by 3. In that case, BC will be 8 and AB will be 6. Got it? The ratio is 4:3 or 4 upon 3. We can also say BC upon AB can also be 12 by 9, which on solving will be 4 by 3. So note that here BC is not 4 and AB is not 3. But we can say BC is multiple of 4, that is it can be 4, it can be 8, it can be 12 like 4, 4 into 1, 4 into 2, 4 into 3. Similarly, AB can be 3, 6, 9, somewhere in this range like 3 into 1, 3 into 2, 3 into 3, somewhere in this multiple range of 3. So here can we write BC as 4k and AB as 3k, where k is any positive number. K can be 1, 2, 3, 4, 5, anything. Got it? BC is 4k. It means BC can be 4 into 1, that is 4, 4 into 2, 8, 4 into 3, 12. It can be anything. Similarly for AB. So we got the perpendicular as 4k and base as 3k. Further in this question, we have to find the other trigonometric ratio. Other trigonometric ratio means we have to find sine A, cos A, cosec A, sec A and cot A. For finding all this trigonometric ratio, we need all the three trigonometric side. That is perpendicular, base and hypotenuse. Two are given, perpendicular and base. Let's find the third missing trigonometric side, that is hypotenuse. So this is a right angle triangle. We can apply the Pythagoras theorem. Note that right angle triangle is very interesting. Two concepts we can apply in a right angle triangle. First is the trigonometric ratio. Second is the Pythagoras. With the help of these two properties, we can solve any missing dimension, any missing angle, any missing side in a right angle triangle. Here we know two sides. We can easily apply the Pythagoras theorem and solve for the third missing side. Let's apply. We got AC square is equal to AB square plus BC square. AC is the hypotenuse, which is the side opposite to 90-degree angle. Let's put the value. On solving, we got AC as 5k. Now we know all the three trigonometric sides of this triangle. We can easily find all the trigonometric ratio. Let's do so. Firstly, sine A. Sine A is perpendicular over hypotenuse, which is BC upon AC. Let's put the value, which is 4k upon 5k. So we got value of sine A as 4 upon 5. Got it? Let's find cos A, which is base over hypotenuse, which is AB upon AC. We know AB as 3k and AC as 5k. K and K will cancel out. We got cos A as 3 by 5. Tan A is already given as 4 by 3. Let's find cosec, sec and cot. In the theory part, we have seen cosec is the reciprocal of sine, sec is the reciprocal of cos, and cot is the reciprocal of tan. Let's find cosec A, which is equal to 1 upon sine A. Sine A we have calculated as 4 upon 5, so cosec A will be reciprocal, that is 5 upon 4. Got it? We got the value of cosec A. Let's find sec A, which is 1 upon cos A, and cos A we have calculated as 3 upon 5. We got sec A as 5 upon 3. Let's find the last trigonometric ratio, that is cot A, which is 1 upon tan A. Tan A, it is given in the question as 4 upon 3. So we got cot A as 3 upon 4. So we got all the 6 trigonometric ratio. That is the answer of this question. Got it? How we have solved this question? We have used the Pythagoras theorem to find the missing dimension. Once we got all the 3 trigonometric sides, we have simply applied the basic formula of all the 6 trigonometric ratios. So that's the solution. Let's move to question number 2. If angle B and angle Q are acute angles such that sine B is equal to sine Q, then prove that angle B is equal to angle Q. So this is the question. Let's observe the question. Let's take two triangles, triangle ABC and triangle PQR. In the first triangle, angle B is the trigonometric angle, and in the second triangle, angle Q is the trigonometric angle. Why we have taken angle B and angle Q as a trigonometric angle? Because in the question it is given sine B is equal to sine Q. Sine B and sine Q, the angle used are angle B and angle Q. So our trigonometric angle for the first triangle will be B, and the trigonometric angle for the second triangle will be Q. Got it? So these are the two triangles, and we have to prove angle B and angle Q is equal to each other. So let's proceed with this question. Here sine B is given as equal to sine Q. Let's find sine B and sine Q. Then we will equate both the values. Sine is perpendicular over hypotenuse, that we have covered in the theory part. So perpendicular for the first triangle will be equal to AC. Perpendicular is the side which is opposite to trigonometric angle. Angle B is a trigonometric angle. So AC is the perpendicular. And hypotenuse is the side which is opposite to 90-degree angle. So AB is the hypotenuse. So we got sine B as AC upon AB. Similarly, for the second triangle, sine Q will be perpendicular over hypotenuse. Here perpendicular is PR and hypotenuse is PQ. Here sine B is given as equal to sine Q. Let's equate both the equations. We got AC upon AB is equal to PR upon PQ. We can rewrite this equation as AC upon PR is equal to AB upon PQ. Further, let's assume these two values as equal to K. That is AC upon PR is equal to AB upon PQ is equal to K. We have just assumed the value as K. Further, these two triangles are right angle triangle. So we can simply apply the Pythagoras theorem in a right angle triangle. Okay. Here let's apply the Pythagoras in the first triangle. AB square is equal to BC square plus AC square. We can rewrite this as BC is equal to root of AB square minus AC square. Similarly, for the second triangle also we can apply the Pythagoras. That will be equal to PQ square is equal to QR square plus PR square. which we can again rewrite as QR is equal to root of PQ square minus PR square. What we have done, we have simply used the Pythagoras theorem to get the value of BC and QR. In this equation, we are having AC and AB and PR and PQ, the two sides of the triangle. The third side is missing in this equation. For the third side, we have applied the Pythagoras theorem and we got BC and QR. Here in this equation, we are having the ratio of AC upon PR and also AB upon PQ. That is the ratios of the corresponding sides of both the triangle. Let's also find the ratio of the third corresponding sides of both the triangle, that is BC upon QR. Let's see what it will be. BC we have calculated as root of AB square minus AC square, and QR we have calculated as root of PQ square minus PR square. Can we replace AB with K times PQ and AC with K times PR? Yes, we can do so. Simply we have used this equation. Here AB will be equal to K times PQ and AC will be equal to K times PR. Let's take K square as common and also K square out of the root. The square will cancel out, K will come out of the root. Here these two terms will cancel out and we got our answer as K. That is BC upon QR is equal to K. If we compare this with the first equation, here AC upon PR is equal to AB upon PQ is equal to K, and we also got BC upon QR is equal to K. So by comparison, we can say AC upon PR is equal to AB upon PQ is also equal to BC upon QR. All these three terms are equal to K. So all these three values will be equal. Here if you observe, these are the ratios of the corresponding sides of both the triangles. Got it? AC is corresponding to PR, AB is corresponding to PQ, and BC is corresponding to QR. So we can say the ratio of corresponding sides of two triangles are equal. Are you able to compare this with the concept of similarities we have done in the chapter number 6? The concept is that the theorem is 6.4. The concept in the theorem 6.4 is that if for two triangles the ratio of the corresponding sides are equal, then the two triangles are similar to each other. Here the ratio of the corresponding sides are equal, it means both the triangles are similar to each other. Once we got the two triangles as similar, it means their corresponding angles will also be equal to each other. That is, the respective corresponding angles are equal. So we got angle B is equal to angle Q, that are the corresponding angle, and also the answer of our question. Angle B is equal to angle Q, that is the answer. Got it? We have done with the question number 2. How we have solved it? What are the concepts that we have applied? The first concept that we have applied is the concept of sine theta. Sine theta is perpendicular over hypotenuse. The second concept we have applied is the Pythagoras theorem. And the third concept we have applied is the concept of similarities of the triangle. Note that in the exam, the simple question involve only one topic of mathematics, for example, only trigonometry. If the question framer want to make the question complex, he or she may mix up 2 or 3 different topics. Like in this question, the concept of trigonometry is mixed with the concept of similarities of the triangle. So you should not miss any of the chapter because the question framer may mix 2 or 3 different topics. If you have not done the similarities of the triangle, check the link in the description. We have covered a complete series on the similarities of the triangle. Check it out. So we have done with the question number 2. Let's move to question number 3. Students, an important thing for you, check the description for the PDF of the complete formula list and also the link to the quiz. Use the formula list to brush up the concept before the exam and the quizzes to check your preparation before the exam. The link to both the formula list and the quizzes are given in the description. Check it out. So let's back to the lecture. Consider triangle ACB right angled at C, in which AB is equal to 29 units, BC is equal to 21 units, and angle ABC is equal to theta. Determine the values of first cos square theta plus sin square theta, second cos square theta minus sin square theta. So let's observe the question. In this question, a triangle ACB is given, which is right angled at angle C. So angle C is the 90-degree angle. Further, angle ABC is also given, that is angle B is given as angle theta. Further, the dimension of AB is given as 29 units and BC is given as 21 units. Dimension of AC is not given in this question. And two part of the question is given. Let's take one by one. In the first part, we have to find the value of cos square theta plus sin square theta. Here theta is used. It means our trigonometric angle is angle theta, that is angle B. It means we will identify the perpendicular, hypotenuse and base with respect to this trigonometric angle, that is angle B. How we will approach this question? We will separately find the value of cos theta and we will separately find the value of sin theta. We will square both the values and we will add them to get our final answer. So this is the approach we will use. First step, we have to find cos theta and sin theta. So what is the formula of sin theta? It is perpendicular over hypotenuse. And what is the formula of cos theta? It is base over hypotenuse. It means we need perpendicular, base and hypotenuse. For this, let's observe the right angle triangle. Let's identify these sides. Here the side opposite to our trigonometric angle is the perpendicular. It means AC is the perpendicular, which is missing in the figure. Okay. And the side opposite to 90-degree angle is the hypotenuse. It means AB is the hypotenuse, which is given as 29 units. So hypotenuse is 29. Further, BC is the base, which is the side between the trigonometric angle and 90-degree angle. Base is given as 21 units, that is BC. So the perpendicular or the side AC is missing. How we will find that? We will apply the Pythagoras property of the right angle triangle, which is AB square is equal to AC square plus BC square, and AC will be equal to root of AB square minus BC square. AB is 29, BC is 21. Let's put the value. Here it is A square minus B square, that is A minus B into A plus B. We can solve this as 29 minus 21 into 29 plus 21. On solving, we got root of 400, that is 20 units. We got the value of AC as 20 units. Now we got all the three trigonometric sides of this triangle. Perpendicular, base and hypotenuse, all the three sides we got. Now we can find any of the trigonometric ratio. Let's find sin theta, which is perpendicular over hypotenuse, that is AC upon AB, which is 20 upon 29. Let's move to cos theta, which is base upon hypotenuse, which is BC upon AB. BC is 21, AB is 29. We got cos theta as 21 upon 29. We got cos theta, we got sin theta, and in the first part we have to find cos square theta plus sin square theta. We know the value, let's square it and let's add it. On solving, we got the answer as 1. The answer of the first part, it is 1. That is cos square theta plus sin square theta is equal to 1. Before moving to the second part, one important thing that you should note is that we got cos square theta plus sin square theta is equal to 1, or sin square theta plus cos square theta is equal to 1. This is an important formula that you will study in the trigonometric identity. This is the beauty of NCERT example questions. They are giving us hint that sin square theta plus cos square theta is equal to 1. The exact formula, the detail we will cover in the trigonometric identity. But now itself they have given the hint for the trigonometric identity formula. Just note that sin square theta plus cos square theta is equal to 1. The detail we will cover in the trigonometric identity. NCERT example questions and the exercise questions are really very good. So don't miss them. Let's move to the second part. We have to find cos square theta minus sin square theta. We know cos theta, we know sin theta. Let's put the value. We got our answer as 41 upon 841. So again, we are also given a hint, that is cos square theta minus sin square theta does not involve any of the formula. Only the formula is the part 1. Got it? So we have done with the question number 3. Let's move to question number 4. Let's move to next example. Example number 4. In a right triangle ABC, right angle at B, if tan A is equal to 1, then verify that 2 sin A cos A is equal to 1. So this is the question. Let's observe the question. In the question, a triangle ABC is given which is right angled at angle B. That is, angle B is a 90-degree angle. Further, it is given that tan A is equal to 1. It means our trigonometric angle is angle A. So this is angle A and this is the trigonometric angle. In all the previous questions, this was our trigonometric angle. But in this question, the upper angle, that is angle A, is the trigonometric angle. So this question will be slightly different as compared to the previous one, and this is the interesting one. In the examination, the question framer may give this type of tricks. So you should firstly identify the trigonometric angle. Here our angle A is the trigonometric angle. Further, we have to verify that 2 sin A cos A is equal to 1. How we will approach that? Somehow we will find sin A and also we will find cos A. We will put the value and we will solve the equation. So this is the approach we will use. Firstly, let's see what is given in the question. In the question, it is given that tan A is equal to 1. And what is tan? Tan is perpendicular over base. So firstly, let's identify what is perpendicular and what is base. In this question, trigonometric angle is angle A. So our trigonometric sides will be slightly different. Let's see. Firstly, let's see what is perpendicular. Perpendicular is the side which is opposite to trigonometric angle. Here our trigonometric angle is angle A, so the side BC is the perpendicular. Got it? Further, hypotenuse is the side opposite to 90-degree angle. Angle B is 90 degree, so AC will be the hypotenuse. And the third remaining side is the base, the side between the 90-degree angle and the trigonometric angle. So AB is the base. And tan A is given as 1. And tan A is perpendicular over base. Perpendicular is BC and base is AB. So tan A is equal to BC upon AB. And tan A is given as equal to 1. So we got BC upon AB is equal to 1. We can also rewrite this as BC is equal to AB. So we got BC and AB both are equal to each other. These two sides are equal to each other. We have just proved. Further, let's assume AB and BC as equal to K. AB and BC both are equal. We have assumed both the side as equal to K. We have done that so that we can get the third side, which is the hypotenuse. We know two sides as equal to K. How we will find the third side? We will use the Pythagoras theorem. That is, AC square is equal to AB square plus BC square. AB and BC are K. So let's solve it. We got AC as K root 2. That is, we got hypotenuse as K root 2. Now we got all the three trigonometric sides. Let's find sin A and cos A. Sin is perpendicular over hypotenuse. So sin A will be equal to BC upon AC. So let's put the value. We got sin A as 1 upon root 2. Further, cos is base over hypotenuse, so cos A will be equal to AB upon AC, which on putting the value and solving, we got cos A as 1 upon root 2. Got it? And in the question, we have to find the value of twice of sin A into cos A. Let's put sin A and cos A as equal to 1 by root 2. On solving, we got our value as 1. That is the required value and that is the answer of this question. Got it? This is important question because our trigonometric angle is not at the usual position. It is on the upper side, and in the previous question we have done in a different way. So for this question, the trigonometric angle is changed, so the trigonometric sides will be different, and further the trigonometric ratios will also be different. So we got this question. Let's move to next question, the example number 5. In triangle OPQ, right angle at P, OP is 7 cm and OQ minus PQ is 1 cm. Determine the value of sin Q and cos Q. So this is the question. Let's observe the question.
In the question, the triangle OPQ is given and the angle P is given as 90-degree angle, and OP is given as 7 centimeter, and we are also given an equation that is OQ minus PQ is equal to 1 centimeter, and we have to find the value of sine Q and cos Q. So how we will find the value of sine and cos? We know sine is perpendicular over hypotenuse and cos is base over hypotenuse. It means we have to find the value of three trigonometric sides. Let's do so. Firstly, let's observe the triangle. Here this is a right angle triangle and angle P is 90 degree, PO is 7 centimeter. And the question is talking about sine Q and cos Q. It means angle Q is the trigonometric angle. So all the trigonometric sides will be with respect to this trigonometric angle. The first step in all these questions is to identify the trigonometric angle. Got it? Angle Q is the trigonometric angle. Perpendicular is the side which is opposite to our trigonometric angle. So the side PO is the perpendicular, which is given as 7 centimeter, and hypotenuse is the side which is opposite to 90-degree angle. So QO is the hypotenuse, and the third remaining side is the base, that is QP is the base. So this is a right angle triangle. We can apply the Pythagoras theorem, that is OQ square is equal to OP square plus PQ square. And in the question itself, it is given as OQ minus PQ is equal to 1. From this, we got OQ is equal to 1 plus PQ. So let's replace OQ with 1 plus PQ in this equation. Let's open the square. We have used A plus B whole square formula. Here PQ square and PQ square will cancel out. Here in the question, OP is given as 7 centimeter. Let's put the value. On solving, we got PQ is equal to 24. So we got the base for this triangle as equal to 24 centimeter. And OQ minus PQ is given as 1 centimeter. We got PQ as 24. So on putting the value, we got OQ is equal to 25 centimeter. That is the hypotenuse. So we got all the three trigonometric sides of this triangle. Now we can easily calculate sine Q and cos Q. Sine is perpendicular over hypotenuse, which will be equal to 7 upon 25. And cos Q is base over hypotenuse, which will be equal to 24 upon 25. That is the answer of this question. Got it? So students, that's it for this lecture. Hope you have enjoyed our creative way of teaching. If you have enjoyed this lecture, if you have gained anything out of this lecture, please like, share and subscribe to our YouTube channel, that is CREATA CLASSES. We add creativity to the learning. And note that this lecture is part of the complete series on trigonometry for class 10 student. The link to the other lectures are given in the description. Check it out. And apart from this, also check out the PDF of the complete formula and concept list, and also the quiz related to trigonometric questions, where you can check the understanding of the trigonometry and the questions. So that's it for this lecture. Bye for now. Best of luck for the exam you are preparing for, and have a great day. Bye.